Welcome to this video lesson on Fermat's factorization method, a smart way to factor large numbers. Let's explore how this method works and why it's useful. In an integer factorization, to factor n is equal to the product of x and y. We do not know the value of x and y. We are only given the value of n. So to find its factors, we can use Fermat's factorization method. However, Fermat's method is most efficient when the number n is odd and the two factors of n are close to each other. In Fermat factorization method, instead of trial division, Fermat uses the concept of expressing the number as a difference of two squares. We write this as n equals x squared minus y squared. Then this right-hand side immediately gives us x minus y and x plus y. So to find such pair of x and y satisfying this equation, we can simply write x squared minus n equals y squared. The first step is to find the smallest integer k such that k squared is greater than or equal to n. So k here is the initial value of x. After that, we can now compute for the value of y squared and check if it is a perfect square. And if not a perfect square, we increase the value of x and continue the process. Once y squared is a perfect square, calculate x plus y and x minus y, and these are the factors of n. Let's go through an example, factor 5959 using Fermat's method. First, we take the square root of n to find the smallest integer k such that k squared is greater than or equal to n. Taking the square root of 5959 equals 77.19. So we find that 77 squared is less than 5959 is less than 78 squared. So let's compute using the formula x squared minus n equals y squared. The initial value of x is 78. We'll start with 78 squared minus 5959 equals 6084 minus 5959 equals 125. Let's check if 125 is a perfect square. Square root of 125 equals 11.18. So this is not a perfect square. So we increase the value of x. We take 79 squared minus 5959 equals 6241 minus 5959 equals 282. Square root of 282 equals 16.79. Still not a perfect square. So we continue the process. Let's take 80 squared minus 5959 equals 6,400 minus 5,959 equals 441. Taking the square root of 441 equals 21. This is a perfect square, then we stop here. We now have x squared equals 80 squared and y squared equals 21 squared. Substituting the values we get to the formula, we have 5959 equals 80 squared minus 21 squared equals 80 minus 21 and 80 plus 21. So using Fermat's factorization method, we get that 59 and 101 are the prime factors of 5959. Let's take another example. Factor 26,549 using Fermat's method. First, we take the square root of n. So square root of 26,549 equals 162.93. So we find that 162 squared is less than 26,549 is less than 163 squared. Let's compute using the formula x squared minus n equals y squared. So the initial value of x equals 163 squared minus 26,549 equals 26,569 minus 26,549 equals 20. Taking the square root of 20 equals 4.47. So this is not a perfect square. So 164 squared minus 26,549 equals 26,896 minus 26,549 equals 347. Square root of 347 equals 18.63. So this is not a perfect square. So 165 squared minus 26,549 equals 27,225 minus 26,549 equals 676. Square root of 676 equals 26. So this is a perfect square, so we'll stop here. Then we have x squared equals 165 squared and y squared equals 26 squared. So substituting the values we get to the formula, we now have 26,549 equals 165 squared minus 26 squared equals 165 minus 26, and 165 plus 26. So using Fermat's factorization method, we now get what 139 and 191.